All right, I'm going to have you open up to the first tab, Properties of Math, in your green notes booklet. And we are going to be writing the notes on this page and then also a few on this page here just to have some notes for today. So what we're working on today is different properties that explain why we solve math problems the way that we do. So there's actually 4 different kinds of properties: associative, commutative, and identity. These 3 a little more self-explanatory. They're a little bit cut and dry to the point. The 4th one is called distributive property, and this one's a little bit more detailed, so that's why it has its own page. So we're going to quickly go through these 3 here, and all you're going to be doing today is being able to recognize what property it is and to make sense of the property and why they have it for the way that they do. So associative property. If you know the word associative or associate, it means to like group yourself or group something with something else. So the associative property is talking about that grouping some numbers together in a problem doesn't affect the sum or the product if it is all multiply or all add. It does not apply when there is subtraction or division in the problem. It also doesn't apply if there's a combination of multiply and add. It has to be all of the same signs or operations throughout it. So if you're looking at this, okay, grouping, which means parentheses, you will see that in this first example, 4 plus 3 is in parentheses. And according to PEMDAS, order of operations, we have to solve what's in parentheses first. So if we were to do that, and I do 4 plus 3 first, 4 plus 3 is 7. Okay, so this is 7. I would then add 7 plus 1, and I get 8. Okay, so I know that my answer is 8 for this problem. But if I were to group this differently and do 4 plus and then 3 plus 1, I would still get my answer as 8, even though they're grouped differently from each other. So 3 plus 1 I know is 4, and 4 plus 4 is 8. So I know that they will equal the same amount. They're just grouped differently. So grouping doesn't affect the sum or the product. Same thing with down here. So 4 with this next to parentheses here means multiply. And you'll see that inside the parentheses, these are being multiplied together as well. So 5 times 8 I know is 40. And then if I do 40 times 4, I get 160. Okay, so 160 is the answer to this problem here. Now, if I group this differently and do 4 times 5 and then multiply by 8 outside, or I can even add a multiply symbol out there in front of the 8, I would group this together and now do 4 times 5, order of operations, parentheses comes first, 4 times 5 first, and I get 20. And then I would do 20 times 8, and I would still get 160. 2 times 8 is 16. Add your 0 on, you get 160. So the associative property is saying grouping doesn't matter as long as it's all add or all multiply. A lot of times you'll notice that this property is being used if there's parentheses attached to any of the numbers in the problem. So look for parentheses with this one. Commutative property is the next one. Commutative property is saying order doesn't affect the sum or the product. And again, it means all multiply or all add. It cannot have subtraction or division in it. And it can't have a combination of multiply and add. It has to be all the same. That's like saying, and even with two numbers here, I know that 2 plus 4 gives me 6. Okay, we all know that. 2 plus 4 is 6. Sorry about that. But if I were to switch them around and do 4 plus 2, I'm still going to get the same answer as 6. Okay, just because they're flip-flopped doesn't mean that they get a different result. Same thing with multiply and even more than one, add or multiply. I could do 8 times 3 times 2. I know that 8 times 3 is 24. 24 times 2 is 48. So I know I'm going to get 48 as my answer for this one. But I could do 2 times 8 times 3, and I would still get the same. 2 times 8 is 16. 16 times 3 is 48. I could also do 3 times 2 times 8, and I would still get my answer as 48. Okay, so it doesn't matter what order they're in, as long as it's all multiply or all add, you still get the same answer. Now, same thing with add. 1 plus 4 plus 9. I know that 1 plus 4 is 5, 5 plus 9 is 14. So I know I'm going to get an answer of 14, but I could also do 9 plus 1 plus 4. I could do 4 plus 9 plus 1. It doesn't matter what order. I'm still going to get 15 or 14 as my answer. Okay? All right, so that is commutative property. I'll add, I'll multiply, I'll add, I'll multiply. Doesn't matter what order it's in. The identity property is a little bit trickier, but not really. You guys already know this for a fact. So a number that's ever multiplied by 1 or added with 0 will result in the same number. So anytime you have seen that a number is multiplied by 1, you're going to get that number that you multiplied by 1. So 8 times 1 is 8. Same thing with if you take that number and you add 0 to it, you're still going to keep that same number you started with. Anytime you multiply by 1 or add 0, your number that you're adding or multiplying with stays the same. So that's the identity property. You're going to look for a 0 or a 1. You're multiplying by 1 or adding 0, you're still going to keep that same number. Now, distributive property, we're going to briefly go into it, but we're going to spend a whole time doing it, or a whole few days actually doing more work on it. But distributive property, really, really quick, is just, we're going to fill out this top bar here, and then we'll go into these examples later on. Distributive property is a single term on the outside of a set of parentheses must be multiplied by all terms inside the parentheses. So distributive property is going to have some parentheses in there too, and it's just saying that everything on the outside has to be multiplied by everything on the inside. So distribute kind of means, if you know this word, distribute means to like equally split or give away, and that's kind of what this outside number is doing. It's equally splitting itself or giving away itself to the numbers on the inside here. Okay, I'm not going to go into more detail with this. Today you're only really going to be working with these first 3 properties, but I wanted to give you these notes just to have them, and then we'll do these practice problems when we get to the distributive property in more detail. Okay, so I will turn back to this page here. If you need to finish up any of these notes, go right ahead and pause this video. Otherwise, you are going to be working on this page that you were either given on Tuesday or that you are given today in class. You are going to be looking at each problem and determining if the 2 things that are given to you are equivalent to each other. So you're going to be solving each one, and if they are, you're going to tell me what property is applied. But if they're not equivalent to each other, you're going to explain why. So I'm going to do this first one with you. So let's solve number 1. Okay, number 1 is saying 2 times the group of 3 times 7 and the group of 2 times 3 times 7 is equal to each other. So we're going to assume that these are equal to each other. So I know that 3 times 7 is 21. 21 times 2 is 42. I know that 2 times 3 is 6. 6 times 7 is 42. Well, these are equal to each other. They are equivalent. So let's look at our green notes booklet and figure out what property is being used. Is it associative, commutative, or identity? And this sheet's only going to work with these 3 here. So I know that grouping is going on, and it's saying that they are separated by parentheses. So grouping is associative property. I'm going to write associative underneath. Okay, so I'm going to solve for each one to show that they're equal to each other. If they are, I'm going to give what property is being represented in the problem here. Okay, so now let's do number 3 since we're on this side of the sheet. So let's solve parentheses. I know order of operations. I need to solve that first. So 9 minus 7 is 2. 26 minus 2 is 24. Okay, now 26 minus 9, that is 17. 17 minus 7 is 10. Well, these are not equal to each other. Okay, now because we solved both of them, we determined they're not equal to each other. We're going to explain why they're not equal to each other. Now look at here. They're trying to do the grouping. They're trying to do the associative property. But associative property subtraction can't follow this. Okay, so because you're using subtraction here, you're not going to get the same answer. You can't group different numbers in a problem with subtraction and expect the answers to be the same. They will not be the same. Okay, so I gave you one example of one that is equal to each other that fits, and you just list the property. If you solve both of these and they're not equal to each other, which is what this little equal sign with the slash through means, you're going to explain why. Subtraction can't follow this. You do not necessarily have to write that it's the associative property, but you can just explain this reasoning here. So subtraction can't follow this. So use your notes booklet. We are only working with associative, commutative, and identity properties on this sheet. Okay? So if you have any questions, feel free to ask. Otherwise, this is due at the end of class today or on your next in-person day.